Hello everyone, and we are back to learning about classes. Now we will talk about constructors and method overloading. When we built our class before, the dog class, we had properties, fields, methods, and the final piece, a type of method, the constructors. What we built is the default constructor for this class. So what is a constructor? A constructor is a method that is called when an instance of a class is created. It is the first method run on an instance of a class, and it is run automatically. So if we go back to our main method, we declared a variable buster of type dog, which is the class we created, and we instantiated it with a new instance of dog. And what's important is the syntax here. When we instantiate an instance of the dog class into the variable buster, we are calling a constructor. What we specify here after new is a call to a specific constructor. The default constructor has no parameters. And in fact, you don't even have to declare a constructor when you build a class. So here, if we were to completely omit the constructor, you can still call the dog constructor because Visual Studio and the .NET compiler automatically creates the default constructor for you. In essence, it would do nothing except create an instance of the dog class. But what we've done here is you can override that default constructor by creating your own. And we were able to use this constructor to set initial values on our class fields. And that's typically what a constructor is used for. When you create a class instance, you want to make sure that that class is filled with either a default set of values or a set of values passed into it to represent something meaningful. So here in a default constructor, we just fill it with default values. However, you can create a constructor that allows you to set certain field settings through the parameters in order to pre-populate values for fields that you can use in your properties and methods. It's a little meaningless if we don't actually build a constructor that does that. So let's again walk through our code. We see at the top we had variable buster of type dog, our dog class, and we instantiated a new dog class. And underneath it, you notice we set the height and the weight and the name. There were three extra lines of code we had to do here in order to set these basic values on the class. If you go back a couple weeks ago when we talked about methods, we talked about method overloading. Essentially, you can have multiple methods with the same name that have different parameters, and these methods can do different things. In this case, we may want to create a constructor that allows us to, at the time of class instantiation, automatically set the height and the weight and the name that is customized to a specific dog. So in here, maybe when we say create a new variable buster of type dog equals new dog, we can automatically type in 1875 in buster and have it fed to the fields of the class. We can do that, and that is the beauty of method overloading on constructors. So by default, we have a constructor of public visibility. When an instance of dog is created, it automatically sets the height to 24 inches, the weight to 50, and the breed to mud. But let's say we may want to customize those. Let's overload the constructor and add some parameters. Int initial height, int initial weight, string breed. And then what we can do is set the field height to the argument passed into the parameter initial height, the field weight to the argument passed into the parameter initial weight, and the field breed to the argument passed into the parameter initial breed. So we've created a method that overloads the constructor dog, also called dog, that accepts three parameters: an initial height, initial weight, and an initial breed. Inside of this method, we're setting the fields height, weight, and breed to the arguments passed in to the parameters on the dog overloaded constructor. So we scroll back up to our main method, and again, important, we've set public here, so this method is accessible outside of the code of this class. And then what we can do is, if you notice the 3 lines of code from 15 to 17, we can simply type these in, 1875. Oh, and I made a mistake. It's not breed. We want to set the name. Sorry, initial name. Name equals initial name. So we want to set the height, weight, and the name, not the breed. And then going up here, we say a new dog, 1875, and Buster. We can take this code and we can get rid of it. So what have we done here? Instead of just calling the default constructor, or the first method run when a class is instantiated, we are passing in values to a new constructor that we wrote that overloads the default constructor. That new constructor then takes values in as parameters, we're passing them in as arguments, and sets them to 3 fields: the height and the weight and the name. Now, if we were to call display information, the method we wrote before, and I'm going to make this public because we messed with it in the last video. Okay, if we call display information on Buster, and we run the application, we see that everything that we set in there has been passed through. Now the difference we see from the first video is that the default value for breed wasn't set. Why is that? Let's look at the 2 constructors we had. If we were to just call dog and omit the rest of the information, we call this constructor. If we were to pass in the 3 parameters, we call this constructor. But the difference is here, we define breed and set a default value. So another commonly used trick when calling constructors is to call constructors from constructors. So here, in public dog, the overloaded constructor, we can call the default constructor from the overloaded constructor, which is also called a parameterized constructor. However, there's a problem. Notice we get an error. Not good. So how do we do that? C# does not allow you to call constructors from inside constructors. They're special types of methods. They're not traditional methods. And in order to call a default constructor before you start setting values, you use a special syntax. In the method definition, put a space, a colon, this, and 2 parentheses. This is a keyword that represents an instance of the class. You can actually use this inside of your class, and it represents this specific instance of the class. It's equivalent to this in the English language. This instance, this. So what we're doing here, this actually refers to the default constructor. So what we're doing when we call the parameterized or overloaded constructor here, Buster equals new dog, 1875 Buster, calls this constructor, but first it calls this, open parentheses, close parentheses, which represents the default constructor. So first this code is run, and then this code is run. So now if we run the application, we see the breed has now been filled in, even when we are using the parameterized constructor for dog. There's also a special method you can use called a destructor. So a constructor is run when a class is instantiated, and a destructor is called when a class instance is destroyed. For the purposes of your time here, you do not need to write or create destructors. But an example of a destructor would be to call the method just like you do with the constructor dog, but you do it using a tilde in front of it, and then maybe you want to write to the console .writeLine debug.line. The reason that we're using debug is the class is destroyed when the application is closed, or you explicitly destroy it. So here, and I will show this to you in the debug window instead of the console. But again, this is not important right now. I just want you to be aware of the syntax of destructor and when it's run. We'll run this application. We'll hit enter. The application ended, and you'll see in the output here, class destroyed. That was when the application ended, that destructor was run and the class was destroyed. You wouldn't see that normally in a console window unless you explicitly destroyed the class instance you created. Destructors are mostly used when you're trying to manage memory. If you have no need to explicitly manage memory, then there's no need to create a destructor. And a lot of times in .NET, because you're letting the .NET framework handle memory management for you, you don't really need to use a destructor. Destructors are important if you're trying to create a log file or track down a problem as to why an instance of a class was destroyed. So you can use it to log things or write to the debugger. However, in your normal coding practices, there's no need to use destructors, but it is here. So for the other examples, I'm just going to go ahead and be rid of the destructor, and it will not be on a test or an assignment. However, it is there for your use if you choose.